Hello, world. I am Saul Luzenaris, and I believe I just created the world's biggest number. Now, that is an extremely large case to even talk about, but what I've just done, or what I've created here, is an extremely large number. This is not like a billion. This isn't a trillion. Those numbers are nowhere compared to the number I created. Now, if we're talking about size of a number, like Graham's number, Tree Three, Rayo's number, all those numbers are extremely large, so large to, in fact, you can't even comprehend it in your own mind. Uh, if you were to try to comprehend them, your mind will literally collapse into a black hole. That's how much information is in one of those numbers. Like Graham's number, I did my research on it like a couple months ago, and it's crazy how freaking nutty of a number that is. But I believe I created a system, and I created you can say variable that allows us to create extremely large number. And I think that it is the largest number because there is no way it can't be. So here you go. So here is how it's gonna go. I don't know how to show it. Sorry, I actually wrote it down. But hold up. Actually, let's just put it right here. Anyways, so I'm going to call this number Saul's number after me, obviously. It's going to be called Saul's number, and then it's going to be called the Saul numbers. So numbers are how you get to that number, basically like a function. So this is what Saul's number looks like. Right here. That little thing right here, Saul to a Google. Trust me, it's enormous. How are we going to get there? So one thing I want to explain to you is something that I created today. I think today is March 30th, I believe, of 2023. I don't know. I forgot the date, but it doesn't matter. It doesn't matter what day it is. But today, the day I post this or whatever, I created a way of achieving extremely large numbers. And this symbol, I'm going to call it SE, Saul's exponent, SE for short. This exponent this variable, or, like in Graham's number, that little arrow, that little thing, I don't know what to call it. But that arrow, like how you would call that, that's what I'm going to be using and defining today. So what is an SE, or what is a Saul's exponent? So it looks like this. That right there. So it's an arrow with a line below it. Now, in mathematics, there might be a symbol defined with that notation, but I'm going to call it SE. As of right now, I do not know if there's any variable or any thing defined as that notation, but we're going to call it SE. Now, what does an SE do? That is the biggest question, and that's a question I've been dealing with for a couple days. And how I'm going to explain to you is defining an actual Google, 10 to the power of 100. Now I can define a Google using SE, and that is this: 10 to the 1 SE to the 10. That's how you write it. 10 to the SE of 10. Right? I don't know if this is backwards. I don't know if you have to flip it or whatever. But yes. So it's 10, the notation SE, and 10. Okay? Now, that equals a Google. And I'm about to show you how it works. So I'm going to write it all out. One, two, three, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so look at that. 10 to the SE of 10 is this large number. Now, if we use the power or if we use the rules of exponents, we can just simply write or add all those exponents up and write 10 to the power of 100, right? So that equals 10 to the SE of 10. Now, to explain it, it's hard to explain, but to explain it in a way that makes sense is, right? So whatever number is, so whatever number is first, right? So 10 is the number that's first. Is going to be raised to the power of 10 and written 10 times. Written 10 times. So that power of 10, so 10 to the power of 10, is going to be written 10 times. So that's how we get a googol. That's how I can define a googol using SE, which I think makes it logical and makes it valid, okay? Because googles are really used to explain really large numbers. But that's nowhere close to the first Saul number, which is Saul of 1. It's nowhere even close. But let's say we add another SE, right? Another SE, which is 10 to the 2 SEs of 10, right? So 10 to the 2 SEs of 10. Now, we are exponentially growing at an extremely high rate. Now, instead of going from just a googol, we're going to a number that cannot be written down, but can be simplified in terms of words. So, or I can show you just the first part of it. So just like that, it'll be 10 to the power of 10 to the power of 10 multiplied 10 to the power of 10 to the power of 10. And now this continues to the 10 to the power of 10 times. Now look at this. It's about to get crazy when you look at this. So double arrow, not double arrow, but double SE10. So 10 to double arrow 10 is 10 to the power of 10 to the power of 10 times 10 to the power of 10 to the power of 10 times 10 to the power of 10 to the power of 10 for 10 billion times. 10 billion times. And that is, or however that number is extremely large. And that number is 10 double SE10. But where do we get Saul's number from? And Saul's number for Saul number 1, for the first Saul number, is 4 SEs to 10. Now, this number is extremely large. It is unfathomable how large this number is. Because we're literally doing 10 to the power of 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 10. Because that's 4 exponents, right? Yeah, that's 4 exponents. To the power of 10 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 times 10 to the power of 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 10. Now this continues to 10 to the power of 10 to the power of 10 to the power of 10 times. Now look at this. Look at this. So 4 SEs is 10 to the power of 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 10 multiplied to multiply to itself this amount of times. And that is the first Saul number. Now, 10 to the 4 SEs of 10 is Saul of 1. We just defined Saul of 1 with this enormous number. And now we have to try to get to Saul of a googol. Now, just like how we're doing it that way. Now I'm gonna show you how to get to Sol 2. And Sol 2 is not like Graham's number where you take the previous number and you go to that amount of arrows. That's not it. It's actually way more crazy than that. Way more bigger than that. Way more crazy than that. It's extreme. So let's try to get to Sol 2. So Sol 2 is equal to 10 to the SE of Sol 1 times. So Sol of 2 is equal to 10 with the amount of SEs of S1 to the 10. Now, this Sol of 2 is extremely large. Extremely large. But it comes nowhere close to Sol's number. Okay? But how can we get to Sol of 3? You might be wondering. Sol of 3 is 10 to the SE of SE to the SE dot 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 SE of 10. So instead of following Graham's rule of just putting this one as Sol of 2, it's actually Sol of 1 times Sol of 2. And that is Sol 3. And what about Sol of 4? What about Sol of 4? If we continue with that, right? We continue with that. 10 to the SE to the SE to the SE dot 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 to the SE of 10, right? Let's make a notation, or let's make a substitution. Let's make a substitution, okay? So Sol 1 times Sol 2, let's substitute it with U, right? Let's say Sol of 1 times Sol of 2 equals U, okay? Equals U. So for Sol of 4, we do U times Sol of 3. Bro. And that's just the amount of SEs. And we know how crazy SEs get. That is Sol 4. Now, let's say we continue going on with this. All the way to Sol of a Google. Okay? Basically saying from Sol of 1 multiplied by Sol of 2, Sol of 3, Sol of 4, all the way to a Google, or one less than a Google, multiply all that together. And that is Sol of a Google. Now that is an extremely large number. I don't think any number like Rayo's number, Graham's number, Tree 3, I don't think those numbers come into fruition of Sol of Google. Now this is an exponential. I don't know if that is even allowed if you're talking about big, humongous numbers. Especially watching videos like the big math debate of who can create the biggest number. I don't think or fathom that maybe this is not allowed, but I think if it is allowed, if we're going by just axioms, I think that this is an extremely large number, and I think the way it grows, the way it exponentially grows itself, is just so unfathomable to even think, to even comprehend. I don't think there's a number or a way of creating something that is even bigger than Sol of Google. Obviously, you can just do Sol of Google plus 1 and immediately beat my number, obviously. But if we're just talking about raw arithmetic or whatever you want to say it, things, I'm in calculus. So, I mean, you can do whatever you want. But I think just thinking about this is extreme. And Sol of a Google, I believe, and I just hope that if we're thinking of this logically, I believe that this is larger than any number that we have come up with as humanity, as a human race. Now, I could be extremely wrong. There could be someone out there who created a number so freaking humongous that Saul's number is closer to 0 than to infinity, or closer to 0 than that number. I believe that Saul numbers grow so exponentially and so greatly that no other number, in my opinion, comes close to it. That is all for me. I don't know if this is a world record. I don't know if this is anything. I just wanted to share my idea with the world, and that Saul numbers and SEs and are just extremely humongous, especially if we can define finite numbers that are already comprehensible, like a Google, that can be written, that I can define it using my notation and using my exponential. I hope that this goes out to the math community. I am not a mathematician. I'm just a student learning math. I'm as far as to differential equations in AP calculus. So just wanted to throw out to the world my idea of Saul numbers. I hope that this can be an inspiration to those who want to create big numbers, that they can, and that you will. And through math, because math is infinite, you can make anything. I believe that you can create your own number, and you create your own biggest number. And maybe it's not compared to mine. Maybe it's not compared to as big as my number, but maybe you can create a number that you think that is extremely large. Now, Saul of a Google is not infinite. It's nowhere near infinity. It is not even the least, it's not even the closest number to infinity. There's probably numbers that we haven't even thought of that is even bigger than Rayo's number or Tree 3 or any type of number. There's always a +1. But I just wanted to share what a Google is. I hope that this can be shared. Hope that this can get to actual real mathematicians so that they can actually grade this, because I think that it is healthy for an 18-year-old like me to get criticism, to get advice in continuing this mathematical craziness that is Saul's number. But it's extremely large. And I think that for you to even try to compute Saul 1 is so unfathomable, or Saul 2, that Graham's number doesn't even come close. Or God knows, Tree 3 doesn't even come close. That if you try to comprehend this size of a number, maybe just double SE, or 10 to the double SE 10, you cannot comprehend that number. That number is too large for your mind to comprehend. It's so enormous that it'll literally create a black hole, another black hole in your mind. Thank you, world, for listening. I hope you understand. If there's anything that you guys have questions about, I hope you can understand Saul's numbers. And just wanted to throw it out. And maybe you can create your own big number using SE. And SE is defined as, oh yeah, I have to define SE too. So before I go, let me define SE. So the notation is very human-like. So just like Graham's number, right? As you see, 3 arrow 3, right? If you do 3 arrow 3, 3 arrow 3. That's 3 to the power of 3, right? So just like that, I'm using the exact same method, but I'm using tens. So 10 SE of 10 is you're taking 10 to the power of 10. But that line under it is also implying that you have to multiply it by the number of that's the last number. So since it's 10 SE10, or let's say it's 10 SE1, right? 10 SE1, right? Oh, I'm sorry. 10 SE1, that is just 10 to the power of 10, which is just 10 billion, if I'm corrected, 10 billion. Because the number at the end, all it's implying is that how many times that this number gets multiplied to itself. So if you guys can understand what an SE is and how to use it, trust me, you can create extremely large numbers with this. You can put a trillion SE a trillion, and you will get a freaking large, humongous number. Saul exponents, I believe, are not the greatest, because I've never like searched up any videos of other people's largest numbers or anyone trying to compete with Graham's number or Tree of Three. I haven't personally seen any of those videos, so I don't know how original my idea is. But I created a notation, and I created a function that grows so exponentially that I don't think anything can even come close to it. So this however minute long video this is, I hope that you can watch all of it, and I hope you understand where I am going with this. Now, this is an extremely unfathomable number, but I do hope that you understand it and that it is practiced, because what any other human would want is for someone to acknowledge his number. But God bless, and I'll see you on the other side.